Imagine living more than 250 miles above Earth, sealed inside a metal structure, where there is no fresh air drifting in, no running water, and no way to throw anything away. Every breath you take, every sip of water you drink, and every bit of waste you produce must be managed perfectly. For the International Space Station, the greatest challenge was never reaching orbit. The real challenge was surviving there continuously, reliably, year after year. On Earth, life support systems are largely invisible. Plants absorb carbon dioxide and release oxygen. Water cycles naturally through rivers, clouds, and rain. Waste slowly breaks down and re-enters the environment. In orbit, none of this happens. The space station is a completely sealed habitat. If oxygen levels drop, there is no atmosphere to borrow from. If water is wasted, it cannot be replaced easily. Every resupply mission costs enormous amounts of money and can only carry a limited payload. Relying on constant deliveries from Earth was never a sustainable solution for long-term human presence in space. Engineers quickly realized that the ISS would need to function more like a living organism than a spacecraft. Everything had to be reused. Everything had to be monitored. And nothing could be allowed to fail quietly. This led to the development of a tightly integrated life support network designed to keep astronauts alive using what they already had. At the heart of the system is a closed-loop approach. When astronauts breathe, they release carbon dioxide into the cabin air. Instead of letting that build up, the station captures it and removes it from circulation. Oxygen is then produced on board by splitting water molecules using electricity. The oxygen is released back into the cabin for the crew to breathe, while the remaining hydrogen is either safely vented or reused in other chemical processes. In this way, air is constantly renewed without relying on external supplies. Water follows a similar philosophy. Moisture from the air, water used for hygiene, and even urine are all collected and processed. Through a combination of filtration, distillation, and chemical treatment, this water is purified to an extremely high standard, often cleaner than drinking water on Earth. More than 90% of the station's water is reused, drastically reducing the need for resupply missions. Temperature and pressure are controlled just as carefully. Humans and electronic systems generate heat, and in the vacuum of space, that heat cannot simply dissipate on its own. The ISS uses large external radiators to release excess heat into space, while internal systems regulate air pressure and circulation to keep conditions comfortable and safe. Sensors constantly monitor these variables, allowing engineers on the ground and astronauts on board to make precise adjustments when needed. A common misunderstanding is that the ISS is regularly refilled with air and water from Earth. In reality, modern crews depend largely on what the station can produce and recycle on its own. Another misconception is that these systems operate entirely on autopilot. While much of the process is automated, human oversight is critical. Astronauts routinely inspect equipment, replace components, and respond to anomalies, working closely with teams on the ground to ensure nothing goes wrong. The importance of this system extends far beyond the space station itself. The same technologies developed to recycle air and water in orbit are now influencing advanced water purification systems on Earth, life support designs for submarines, and emergency infrastructure for disaster zones. Most importantly, these systems are essential for future missions beyond low Earth orbit. Long-duration stays on the Moon or missions to Mars would be impossible without reliable, closed-loop life support. In the end, the most remarkable achievement of the International Space Station is not its size, its speed, or the experiments it hosts. It is the quiet, continuous engineering that allows humans to survive in an environment where life cannot naturally exist. The ISS does more than circle the planet. It demonstrates that with the right systems in place, human life can be sustained almost anywhere. And perhaps the most important lesson it teaches is this: the future of space exploration depends less on powerful rockets, and more on how efficiently we can reuse what we already have.